Welcome to our deep dive into the mysterious world of the deep sea. It is a realm of perpetual twilight, then utter blackness, a place of crushing pressures and chilling temperatures. An environment so alien it might as well be another planet. Yet within these seemingly inhospitable depths, life not only exists but flourishes in forms so bizarre, so wondrous, they defy our everyday comprehension. These are the frontiers of our knowledge, where every expedition, every submersible dive brings forth new marvels and deepens our understanding of life's tenacity and its extraordinary capacity for adaptation. The abyss guards its secrets jealously, but occasionally it offers us glimpses of its inhabitants. Today we're uncovering the top 10 deep-sea creatures you've probably never heard of. These are not the familiar denizens of sunlit coral reefs or coastal waters, but rather the elusive, the strange, the truly unique organisms that have carved out an existence in the most extreme conditions imaginable on Earth. We will journey thousands of meters below the surface, into zones where sunlight never penetrates, to meet creatures that generate their own light, possess astonishing hunting strategies, and exhibit forms and functions that seem plucked from the pages of science fiction. Prepare to be astonished by the sheer diversity and ingenuity of life in the deep. This exploration is more than just a catalogue of the curious, it's a testament to the incredible evolutionary pathways life can take. Each creature we encounter tells a story of survival against unimaginable odds. A narrative written in the language of bioluminescence, specialized anatomy, and behaviors honed over millennia in the dark. Join me as we illuminate these hidden corners of our planet and meet the extraordinary beings that call the deep sea their home. It is a journey that promises to expand our appreciation for the vast, unexplored wilderness that lies beneath the waves, a wilderness teeming with life that continues to surprise and inspire. Our first subject, residing in the abyssal depths, often thousands of meters below the surface, is a creature of unexpected charm and grace, the Dumbo octopus. Named, rather endearingly, after the famous elephant calf from Disney's Imagination, this cephalopod earns its moniker from the prominent ear-like fins that protrude from the sides of its mantle. These are not merely decorative appendages, they are its primary means of locomotion. With slow, rhythmic pulses of these fins, the Dumbo octopus appears to fly through the water, a gentle, almost ethereal ballet performed in the crushing blackness of its home. It is a sight that evokes a sense of serene beauty, a stark contrast to the harsh environment it inhabits. Unlike its shallow water cousins, the Dumbo octopus, belonging to the genus, does not rely on jet propulsion as its main mode of transport. While it possesses a siphon and can expel water for a burst of speed if necessary, it is the graceful undulation of its large fins that characterizes its movement. This method is remarkably efficient for navigating the still, cold waters of the deep sea, allowing for precise control and a stealthy approach to both prey and potential mates. Its body is soft and gelatinous, an adaptation that helps it withstand the immense pressures found at depths of up to 7,000 meters, nearly 7 kilometers straight down. These octopuses are relatively small, typically reaching sizes of around 20 to 30 centimeters, though some individuals of certain species can be larger. They are demersal creatures, meaning they live and feed on or near the seafloor. Their diet consists primarily of small crustaceans, bivalves, worms and copepods that they find drifting in the water column or scurrying across the abyssal mud. Lacking an ink sac, a common defensive tool for other cephalopods, the Dumbo octopus likely relies on its deep-sea habitat, camouflage, and perhaps its surprisingly agile movements to evade the few predators that can survive at such extreme depths. The ears are, in fact, highly modified fins supported by an internal cartilaginous shell, a remnant of an ancestral feature. Watching them, one is struck by their almost whimsical appearance, a reminder that even in the most forbidding environments, nature can produce forms of delicate artistry. They hover above the seabed, their 8 webbed arms trailing below, perhaps sifting through the sediment or poised to envelop an unsuspecting meal. Their large eyes, though adapted to the minimal light, are crucial for detecting the faint bioluminescent signals of other organisms or the silhouettes of prey against the even darker background. Observing the Dumbo octopus is a privilege usually only afforded by remotely operated vehicles or ROVs equipped with powerful lights and cameras. Each encounter provides valuable data, helping scientists piece together the life history of these enigmatic animals. They're a testament to the diversity of cephalopod evolution, showcasing how this intelligent group of invertebrates has conquered even the most challenging marine environments. The Dumbo octopus, with its gentle flapping and ghostly presence, remains one of the deep sea's most captivating and surprisingly endearing ambassadors. Next, we encounter a creature that seems to have swum directly out of prehistoric times, the goblin shark. This is not a shark one is likely to encounter during a casual swim. It is a denizen of the deep ocean, typically found along continental slopes and seamounts at depths greater than 200 meters and sometimes far deeper, exceeding 1,300 meters. Its most striking feature, and the one that lends it an almost nightmarish visage, is its extraordinarily long, flattened snout resembling a blade which protrudes far forward from its eyes. Beneath this peculiar rostrum lies a set of highly protrusible jaws, filled with slender needle-like teeth. The goblin shark is often referred to as a living fossil because it is the sole extant representative of the Mitsukurinidae family, a lineage that dates back some 125 million years. Its appearance has changed little over these vast swathes of geological time, a testament to a successful, albeit highly specialized body plan. Its skin is a peculiar pinkish-grey hue, a result of blood vessels showing through its semi-transparent dermis, as it lacks significant pigmentation, a common trait in deep-sea creatures where camouflage relies less on color and more on an absence of light. This coloration gives it an almost ghostly, somewhat fragile appearance, belying its predatory nature. The true marvel of the goblin shark, however, is revealed when it hunts. That elongated snout is packed with ampullae of Lorenzini, electroreceptors that can detect the faint bioelectric fields generated by the muscle contractions of small fish, squid and crustaceans moving in the dark. Once prey is detected, the shark's jaws, normally held flush with its head, are thrust forward with astonishing speed and reach. This slingshot mechanism allows it to snatch prey that might otherwise be out of range. A crucial adaptation for a relatively slow-swimming predator in an environment where meals can be few and far between. The jaws themselves are a biomechanical wonder. They can extend almost to the end of its snout, effectively doubling its reach in an instant. This rapid protrusion is achieved through a complex interplay of ligaments and muscles, allowing the shark to ambush its prey with startling efficiency. The teeth, long and sharp, are perfectly designed for grasping slippery prey, ensuring that once caught there is little chance of escape. Despite its fearsome appearance and hunting prowess, the goblin shark is not considered a threat to humans, primarily due to its deep water habitat and its preference for smaller prey. Encounters with goblin sharks are rare, and much of what we know about them comes from accidental catches in deep-sea fisheries. Each specimen provides invaluable information, helping scientists understand more about its biology, behavior, and distribution. The goblin shark remains one of the ocean's great enigmas, a creature that embodies the ancient alien nature of the deep sea. It is a stark reminder of the incredible diversity of life forms that have evolved in ways we are only just beginning to comprehend, a true relic from a bygone era, still patrolling the silent, sunless depths. Journeying deeper still, into the oxygen minimum zones where few creatures can survive, we find the enigmatic vampire squid, which translates rather dramatically to vampire squid from hell. Despite its intimidating name and appearance, this creature is not a bloodsucker, nor is it technically a squid or an octopus, but rather the sole surviving member of its own unique order, Vampiromorphida. It is a living relic sharing characteristics with both octopuses and squids, and it has carved out a niche in one of the ocean's most challenging environments. The vampire squid is relatively small, growing to about 30 centimeters in total length. Its body is cloaked in a velvety black or reddish-brown webbing that connects its 8 arms, giving it the appearance of a cape. When threatened, it can invert this cape over its body, a defensive posture aptly named the pineapple posture, which exposes rows of fleshy spines called cirri on the underside of its arms. This remarkable maneuver makes it appear larger and more intimidating, and protects its more vulnerable head and mantle. Its eyes are proportionally the largest of any animal on Earth relative to its body size, allowing it to capture every last photon of light in the dim abyss. One of the most fascinating adaptations of the vampire squid is its ability to thrive in the oxygen minimum zone, OMZ, typically found at depths between 600 and 1,500 meters. Here, oxygen levels are so low that most complex organisms cannot survive. The vampire squid, however, has an exceptionally low metabolic rate and a highly efficient blood pigment, hemocyanin, that binds and transports oxygen effectively even at very low concentrations. This allows it to exist where predators are scarce and competition for food is reduced, a unique strategy for survival in the vastness of the deep ocean. Instead of hunting live prey like its more active cephalopod relatives, the vampire squid is a detritivore, feeding on marine snow, a shower of organic detritus, dead plankton, fecal pellets, and mucus that drifts down from the more productive upper layers of the ocean. It uses two long, retractable sensory filaments unique to its order to detect and collect these particles. These filaments, which can extend to many times its body length, are then drawn through its arms, and the collected food particles are scraped off and consumed. This passive feeding strategy is perfectly suited to its low-energy lifestyle and the sparse food availability in its habitat. The vampire squid also possesses remarkable bioluminescent capabilities, though not for attracting prey. It has photophores, light-producing organs scattered over its body, particularly on its arm tips. It can control the intensity and duration of these light emissions, possibly to confuse predators or for communication. When startled, it can eject a cloud of sticky bioluminescent mucus, a dazzling display that can momentarily blind or distract an attacker, allowing the squid to escape into the darkness. The vampire squid is a true master of adaptation, a creature of subtle beauty and extraordinary resilience, perfectly attuned to its dark, oxygen-starved world. Chapter 4 takes us deep into the bathyal zone, often called the twilight zone, where only the faintest vestiges of sunlight penetrate. Here we encounter a formidable predator, the deep-sea dragonfish. Now, this isn't just a single species, but a whole family of fishes, the Stomidae, known for their fearsome appearance and sophisticated hunting adaptations. Many of these species have elongated, dark bodies, large mouths filled with fang-like teeth, and an array of bioluminescent organs, or photophores, that serve multiple purposes in the perpetual gloom. They're the quintessential ambush predators of the deep. One of the most striking features of many dragonfish is a prominent chin barbel, a long, whisker-like appendage that dangles beneath their lower jaw. This barbel is often tipped with a bioluminescent lure, which the dragonfish can flash or wiggle to attract unsuspecting smaller fish and crustaceans. The lure can vary greatly in complexity and color between different species, a testament to the evolutionary pressures of attracting specific prey in a diverse, dark environment. The unsuspecting victim, drawn by the promise of a meal or a mate, swims closer, only to find itself within striking distance of the dragonfish's formidable jaws. The teeth of the deep-sea dragonfish are truly impressive, long, sharp, and often transparent, making them nearly invisible in the dim light. In some species, like the Sloane's viperfish, the teeth are so large that they can't even fit inside the mouth when it's closed, curving back towards the eyes. This dental armament ensures that any prey captured has little chance of escape. Their bodies are typically black or dark brown, providing excellent camouflage in the low-light conditions, rendering them virtually invisible until they choose to reveal themselves with their luminous displays or a sudden, swift attack. Perhaps one of the most remarkable adaptations of certain dragonfish, particularly those in the genus, the loosejaws, is their ability to produce and perceive red light. Most deep-sea creatures can only see blue light as it penetrates deepest in the water column. Red light, with its longer wavelength, is quickly absorbed. However, these dragonfish have specialized pigments that allow them to emit red bioluminescence from photophores near their eyes. They also possess retinal pigments capable of detecting this red light, effectively giving them a secret sniper scope to illuminate prey that cannot see the red beam, a significant predatory advantage. These hunters are built for a life of energy conservation, punctuated by bursts of predatory activity. Their bodies are often somewhat fragile, with minimal skeletons and watery flesh. Adaptations to the immense pressures and the need to remain neutrally buoyant without expending too much energy. The deep-sea dragonfish, in its many varied forms, exemplifies the extreme adaptations necessary for survival as a predator in the deep ocean. A world of darkness, deception, and deadly efficiency, where light, or the clever manipulation of it, can mean the difference between a meal and starvation. Chapter 5 introduces us to another fascinating deep-sea dweller, the giant isopod and its relatives. These creatures take us to the very floor of the deep ocean, to the vast, muddy, abyssal plains, looking like an oversized version of a common woodlouse or pillbug, to which it is indeed related. This crustacean is a truly remarkable example of deep-sea gigantism. While its terrestrial cousins might barely reach a centimeter or two, the giant isopod can grow to astonishing lengths, some specimens exceeding 50 centimeters and weighing over 1.5 kilograms. This makes them one of the largest crustaceans found in the deep sea. These creatures are primarily scavengers, playing a vital role as decomposers in the deep sea ecosystem. They patrol the seabed, often at depths ranging from 170 meters down to over 2,100 meters, in search of any organic matter that drifts down from the upper layers of the ocean. This includes the carcasses of whales, fish, and squid that sink to the ocean floor, providing infrequent but substantial feasts. When such a bounty is discovered, giant isopods will congregate and gorge themselves, sometimes eating so much that they become temporarily immobile, their bodies visibly swollen. The giant isopod's anatomy is perfectly suited for its lifestyle. It possesses a tough, calcified exoskeleton segmented into overlapping plates, which offers protection against the immense pressure and potential predators. It has 7 pairs of legs, or paraeopods, allowing it to move with surprising agility across the soft sediment. Its compound eyes, though large, are adapted to the extremely low light levels of its habitat and may primarily detect movement or bioluminescence. They also possess 2 pairs of antennae, which are crucial sensory organs for detecting chemical cues in the water, helping them locate distant food falls. One of the most incredible adaptations of the giant isopod is its ability to survive for extraordinarily long periods without food. In an environment where large food falls are unpredictable and scarce, this is a crucial survival mechanism. They have a very slow metabolism, and when food is abundant, they can store large amounts of lipids. Captive specimens have been known to go for several years without eating, a testament to their extreme adaptation to a feast or famine existence. This slow pace of life is characteristic of many deep-sea organisms, reflecting the cold temperatures and limited resources. Despite their somewhat alien appearance, giant isopods are ancient creatures, with fossil records indicating their presence in the oceans for hundreds of millions of years. They represent a successful and enduring lineage, perfectly adapted to the challenges of life on the abyssal plains. They are the cleanup crew of the deep, efficiently recycling nutrients and ensuring that nothing goes to waste in this resource-limited environment. The giant isopod, in its patient, enduring existence, offers a profound insight into the rhythms of life in the planet's largest and least explored habitat. Chapter 6 brings us to one of the most iconic creatures of the deep, the anglerfish. Few creatures epitomize the bizarre and fascinating nature of the deep sea, quite like the anglerfish. This diverse group, belonging to the order Lophiformes, is renowned for its unique predatory strategy, bioluminescent angling most famously. The females of many species possess a modified dorsal fin spine, the elysium, which protrudes from their heads and acts as a fishing rod. At the tip of this elysium is a fleshy, often glowing lure, the esker, which dangles enticingly in the inky blackness, mimicking a small marine organism to attract unsuspecting prey. The appearance of the anglerfish is as striking as its hunting method. They typically have large heads and enormous crescent-shaped mouths filled with long, sharp, inward-pointing teeth. Their bodies are often globular or flattened, and their skin can be soft and flabby, aiding in buoyancy and pressure resistance in the deep. Camouflage is key, even in the dark, and many anglerfish are dark brown or black, blending seamlessly with their surroundings until their lure is activated. They are patient hunters, often remaining motionless for long periods, conserving energy until a potential meal ventures too close. The bioluminescent lure is a marvel of natural engineering. The light is produced by symbiotic bacteria housed within the esker, and the anglerfish can control the glow, sometimes flashing it or wiggling the lure to create a more convincing deception. Different species of anglerfish have evolved lures of various shapes, sizes, and complexities, likely adapted to attract specific types of prey found in their particular depth range and habitat. When a curious fish or crustacean approaches the inviting light, the anglerfish can open its massive mouth with incredible speed, creating a vacuum that sucks the victim in, a process that happens in mere milliseconds. Perhaps one of the most astonishing aspects of anglerfish biology is their extreme sexual dimorphism and unique mating strategy, particularly in the serratioid anglerfish of the abyssal zone. The males are tiny, often orders of magnitude smaller than the females. Upon finding a female, a feat in itself in the vast darkness, the parasitic male bites into her skin and fuses his circulatory system with hers. He then physically degenerates, losing his eyes, digestive system and other organs, becoming little more than a pair of gonads attached to the female, providing sperm on demand. A single female may carry several such parasitic males. This bizarre reproductive arrangement ensures that when a female is ready to spawn, sperm is readily available. A crucial adaptation in an environment where encounters between sexes are rare and unpredictable. The anglerfish, with its ingenious lure and extraordinary reproductive habits, stands as a powerful symbol of the extreme evolutionary pathways life has taken to survive and thrive in the crushing pressures and eternal darkness of the deep sea. It is a creature that perfectly embodies the alien beauty and ruthless efficiency required to make a living in one of Earth's most challenging frontiers. Our journey now takes us to encounter a creature that offers a rare glimpse into the distant evolutionary past of sharks, the frilled shark. Often described as a living fossil, this shark possesses a suite of primitive characteristics that distinguish it markedly from most modern sharks. It inhabits the outer continental shelf and upper continental slope, typically at depths between 50 and 1,500 meters, though it has occasionally been found in shallower waters. Its appearance is strikingly serpentine, with an elongated eel-like body that can reach up to 2 meters in length. The name frilled shark derives from the 6 pairs of gill slits that adorn its throat, the first pair of which meets underneath, creating a frilly collar-like appearance. These gill slits are quite distinct from the 5 to 7 individual uncovered slits seen in most other sharks. Its jaws are another primitive feature. They are terminal, meaning they are located at the very front of its head rather than underslung, as in most modern sharks. This, combined with its long, flexible body, gives it a distinctly ancient, almost reptilian look. The jaws are lined with multiple rows of small, 3-pronged, needle-sharp teeth, totaling around 300, a formidable dental array. The hunting strategy of the frilled shark is thought to reflect its unusual anatomy. It is believed to prey primarily on squid, other sharks, and bony fish. One hypothesis suggests that it may lunge at its prey much like a snake, bending its body and striking with surprising speed. Its long, flexible jaws would allow it to swallow prey whole, even items of considerable size relative to its own. The numerous small, inwardly pointing teeth would ensure a firm grip on slippery prey, preventing escape once captured. The dark brown or grey coloration of its body provides excellent camouflage in the dimly lit waters it frequents. Due to its deep water habitat and elusive nature, direct observations of frilled sharks in their natural environment are exceedingly rare. Much of what is known about them comes from specimens accidentally caught as bycatch in commercial fishing operations. These encounters, though infrequent, provide vital information about their diet, reproductive biology, and distribution. They are ovoviviparous, meaning the embryos develop inside eggs that are retained within the mother's body until they are ready to hatch. The gestation period is thought to be extraordinarily long, possibly up to 3.5 years, one of the longest known in the animal kingdom. The frilled shark stands as a remarkable example of evolutionary conservatism. Its lineage is thought to have diverged from other sharks very early in their evolutionary history, and it has retained many features that were common in ancient shark forms. Studying this creature is like looking back through a window in time. offering clues about the kinds of sharks that patrolled the oceans millions of years ago. Its continued existence in the deep sea is a testament to the success of its ancient body plan, a relic of a bygone era, still navigating the dark, cold waters of our planet. We now venture to one of the most extreme environments on Earth, hydrothermal vents. These are fissures in the seafloor, often associated with volcanic activity, from which geothermally heated water spews forth, rich in minerals. Around these oases of chemical energy in the otherwise food-scarce deep sea, unique ecosystems thrive. And here we find a truly peculiar crustacean, the yeti crab. First discovered in 2005, species of the family Kiwidae are named for their remarkably hairy claws and limbs, reminiscent of the mythical abominable snowman. The hairs on the yeti crab's chelae, or claws, and legs are actually setae bristle-like structures. These setae are not for warmth, as one might infer from the name, but rather serve a far more extraordinary purpose. They are home to colonies of filamentous bacteria. The crabs are often observed waving their hairy appendages rhythmically in the mineral-rich plumes emanating from the hydrothermal vents. This behavior is believed to cultivate these symbiotic bacteria, which form the primary food source for some yeti crab species. In essence, they are farmers tending to their bacterial gardens. These bacteria are chemosynthetic, meaning they derive energy not from sunlight, which is absent at these depths, but from chemical reactions, metabolizing compounds like hydrogen sulfide and methane, which are abundant in vent fluids. The yeti crab, by providing a substrate and exposing the bacteria to the nutrient-rich water, facilitates their growth. It then uses specialized comb-like mouthparts to scrape these bacteria off its setae and consume them. This remarkable symbiotic relationship allows the yeti crab to thrive in an environment that would be toxic and barren for most other forms of life. Different species of yeti crabs have been discovered near various types of deep-sea chemosynthetic environments, including hydrothermal vents and cold seeps. For instance, Kiwa hirsuta, the first species described, is found near Pacific Antarctic ridge vents. Another species, Kiwa pura vida, discovered off the coast of Costa Rica at a methane seep, actively waves its claws to encourage bacterial growth, a behavior that earned it the nickname the Hoff crab, due to its seemingly hairy chest. These crabs are typically pale in color and have greatly reduced eyes, often lacking pigment, as vision is of little use in their dark, chemically driven world. The discovery of yeti crabs and the ecosystems they inhabit has revolutionized our understanding of where and how life can exist on Earth and potentially elsewhere in the universe. They demonstrate that complex life can be sustained entirely by chemical energy, independent of sunlight. These fascinating crustaceans, with their unique farming techniques, are a testament to the incredible adaptability of life and the surprising biodiversity that can be found in the most unexpected and extreme corners of our planet, tilling their bacterial gardens in the deep, dark warmth of Earth's inner heat. Our penultimate creature is one whose cranial anatomy seems to defy belief: the barrel-eye fish, particularly species like Macropinna microstoma. Found in the meso- and bathypelagic zones of temperate and tropical waters, typically at depths between 600 and 800 meters, this small fish possesses one of the most peculiar and highly specialized visual systems in the animal kingdom. Its most striking feature is its completely transparent, fluid-filled head, through which its internal, upward-pointing tubular eyes are clearly visible. The eyes of the barrel-eye are truly remarkable. They are large, barrel-shaped, and typically oriented dorsally, looking straight up through the transparent dome of its head. This allows the fish to detect the faint silhouettes of prey swimming overhead against the dimly lit waters above. The transparent shield that covers its head is thought to protect these sensitive eyes, possibly from the stinging cells or nematocysts of siphonophores from which it is believed to steal food. The green pigment in its lenses helps to filter out sunlight, enhancing its ability to spot the bioluminescence of potential prey or predators. For many years it was believed that the barrel-eye's eyes were fixed in this upward-pointing position, which would have severely limited its ability to see what was directly in front of it, particularly when feeding. However, observations of live specimens have revealed an even more astonishing adaptation. The barrel-eye can rotate its tubular eyes forward, This means it can track prey visually as it moves into a position to be consumed by its small, pointed mouth. This ability to switch between dorsal and frontal vision is a crucial adaptation for hunting in its dimly lit three-dimensional world. The body of the barrel eye is relatively small, usually around 15 centimeters in length, and dark in color, providing camouflage from below. It has large, flat fins, which allow it to remain almost motionless in the water column, hovering with great precision while it scans the waters above for food. Its diet is thought to consist of small crustaceans, zooplankton, and, as mentioned, possibly jellyfish and siphonophores. The ability to maneuver delicately and see clearly in multiple directions is paramount for a creature that must both find scarce food and avoid becoming food itself. The barrel-eye fish, with its transparent head and rotating telescopic eyes, is a stunning example of how extreme environmental conditions can drive the evolution of equally extreme and highly specialized adaptations. It is a creature that seems almost alien, a product of the perpetual twilight where vision is a precious commodity and every photon of light can mean the difference between life and death. Studying these incredible fish continues to provide insights into the physics of light and vision in the deep sea and the myriad ways life has found to perceive and navigate its complex dark domain. Our final creature takes us back to the soft, muddy floor of the abyssal plains, a seemingly featureless expanse that is, in fact, teeming with specialized life. Here we encounter the sea pig, a colloquial name for certain species of deep-sea holothurians or sea cucumbers primarily belonging to the genus Scotoplanes. These peculiar echinoderms are characterized by their plump, translucent bodies, often pinkish or pale in color, and their distinctive leg-like tube feet. They truly resemble small, fleshy pigs rooting around in the sediment. Sea pigs are deposit feeders, playing a crucial role in the deep-sea ecosystem, much like earthworms do in terrestrial soil. They move slowly across the abyssal mud, using their specialized oral tentacles to scoop up sediment rich in organic matter. They ingest this mud, digest the nutritious detritus bacteria, foraminiferans and other microorganisms, and excrete the processed sediment. This constant bioturbation, or mixing of the sea floor, helps to oxygenate the upper layers of the sediment and recycle nutrients, making them available for other organisms. They are the unsung gardeners of the abyss. The legs of the sea pig are actually enlarged tube feet, a characteristic feature of echinoderms like starfish and sea urchins. Scotoplanes typically have 5 to 7 pairs of these prominent ventral tube feet, which they use for locomotion across the soft substrate. They also possess several elongated, antenna-like papillae on their dorsal surface, which may serve sensory functions, helping them detect chemical cues or water currents. Their bodies are largely composed of water, giving them a gelatinous consistency that helps them withstand the immense pressure at depths that can exceed 6,000 meters. Sea pigs are often found in large aggregations, sometimes numbering in the hundreds, particularly in areas where food is abundant, such as near recent whale falls or patches of high organic input. These herds of sea pigs can all be oriented in the same direction, facing into the prevailing current, which likely helps them detect food particles drifting along the sea floor. Despite their slow movement and soft bodies, they have few natural predators in the deep, though they are known to be parasitized by small snails and crustaceans. The humble sea pig, with its unassuming appearance and slow-paced life, is a vital component of the deep-sea benthic community. Its activities are fundamental to the health and functioning of the abyssal ecosystem, processing vast quantities of sediment and contributing to the biogeochemical cycles that sustain life in this remote and challenging environment. They remind us that even in the deepest, darkest parts of our planet, organisms, no matter how strange they may seem to us, play intricate and essential roles in the grand tapestry of life. Thanks for joining us on this journey into the deep sea. We've journeyed together through crushing pressures and eternal night to witness but a fraction of the biodiversity that thrives in these hidden realms. From the delicate ballet of the Dumbo octopus to the ancient visage of the frilled shark and the almost unbelievable adaptations of the barrel-eye fish, each creature has revealed a unique strategy for survival in an environment that pushes the very limits of life as we know it. The deep sea is not a barren wasteland, but a vibrant, dynamic, and largely unexplored frontier, holding secrets that continue to challenge our understanding of biology and evolution. The creatures we've encountered today are more than just curiosities. They are integral parts of complex ecosystems, performing roles that contribute to the overall health of our planet's oceans. The ingenuity of the anglerfish's lure, the symbiotic farming of the yeti crab, and the patient scavenging of the giant isopod all speak to the incredible power of natural selection to shape life in response to extreme challenges. Yet, even these remote habitats are not immune to human impact, from climate change to deep-sea mining and pollution. Understanding and appreciating these unique life forms is the first step towards ensuring their protection for generations to come and for the continued health of the global ocean. There is still so much to discover in the abyssal depths. Each new expedition with advanced submersibles and remote sensing technology brings forth new species and new insights into this mysterious world. The quest to explore the deep sea is a quest to understand the full extent of life on Earth. Don't forget to like, subscribe, and hit the bell icon for more fascinating content as we continue to delve into the wonders of the natural world, both familiar and profoundly alien. The abyss awaits, and its stories are far from over.